Welcome to Learning with Philemon. In the previous video, we saw polymers made from an addition reaction between identical alkene monomers. In this video, we will discuss polymers made from condensation. Unlike in addition polymerisation, two different monomers are required for condensation. To form nylon 6,6, you need to react hexandioic acid with hexane 1,6 diamine. Hexandioic acid is a carboxylic acid. It contains a COOH group on both ends of the molecule. Hexane 1,6 diamine is an amine due to the functional group NH2. Note that di is included in both names as the groups appear twice in the molecules. 1 and 6 indicate the position of the amine groups on the carbon chain. For more on naming, please watch the IUPAC naming video. When an amine reacts with a carboxylic acid, the nitrogen atom forms a bond with the carbon of the COOH group, as can be seen by the green bonds. Carbon must only have 4 bonds in total, so its bond with the OH group breaks. The bond between the nitrogen and one of the hydrogen atoms also breaks, so the nitrogen has 3 covalent bonds. The OH and H groups lost form water, H2O. In condensation polymerization, you form both a polymer and water as a byproduct. Note that the end carbon and nitrogen atoms would bond with other monomers, continuing the polymer chain. The diagram only shows one repeat unit. You can have any positive integer of this repeat unit as denoted by n and the square brackets. At GCSE level, this structural formula will often be simplified to this type of diagram. The different colored boxes represent the carbon chains contained within each monomer. By reacting a carboxylic acid and an amine, we have formed an amide, which consists of the functional group CONH. This is also called an amide linkage, which we will see again in the next video on natural polymers. Polymers that contain the amide linkage can also be called polyamides. Nylon 6,6 is a synthetic polymer that is used in the textile industry to make clothing, among other things. It can also be made in the lab. See the link in the description for the method. Now let's take a look at another synthetic polymer. The synthetic polymer terylene is formed from the following two monomers: ethane 1,2-diol, an alcohol, and benzene 1,4 dicarboxylic acid. For more information on this 6-membered carbon ring, please watch the IB higher level videos. As seen in the carboxylic acids and esterification video, when carboxylic acids react with alcohols, a bond is formed between the oxygen of the alcohol and the carbon of the COOH group, as shown by the green bond. Like in the previous example, water is lost as a byproduct. This structural formula can be simplified to this diagram. Note that in this case, we have an ester linkage. Esters contain the functional group COO. Polymers that contain the ester linkage can also be called polyesters. Terylene, like nylon 6,6, is also used in the textiles industry. Please watch the previous video on addition polymers if you still do not understand the process of polymerization. Watch the next video if you want to learn about natural polymers. Thank you for listening. To consolidate your learning, try to answer the questions in the description. If you haven't already, please subscribe for more content. Stay curious.